Well, good morning, everybody. Good morning, everybody. Good morning, everybody. It's a brisk Saturday morning here in Ellensburg, Washington, USA. This is the final show. Thank you for joining us. The local time is 8:48, and we will begin our program at the top of the hour. About 12 minutes from now. Five by five. Thank you. Since we have 3 guests, I'd like to email them right away, get them all safely tucked into the green room, and then we can say some highs to each other. What? All right, so give me a second, would you please? I'm still seeing 5 by 5s, and that's always comforting to see. Sending an email to Basil Tikoff in Madison, Wisconsin, Karin Sigloch in Nice, France, and Stephen Johnston in Edmonton, Alberta. And there it goes. It really is magic when you think about it. Spreading Ridge, John Nash this morning. Hello. Good morning, John. Eric. Where are you viewing from, please? Love to say hi to as many of you as possible. Hollister, California. Oh boy. I'm gonna slow this down. What do we got? More than almost 400 already. Kamloops, BC. Indiana. Hello. West Allis, Wisconsin. The Commonwealth of Virginia. Commonwealth of Massachusetts. What the? Menominee, Wisconsin, Kamloops, BC, I think I already said that. Maybe that's another person, Bob. Spokane Valley, Anna in Finland. Hello, that's Tampere, Finland, for those scoring at home. Come on, let's go. Kirk and Göteborg, Sweden, Dallas, Texas, Waikele, Hawaii, Newport, Oregon, Troutdale, Oregon, Red Deer, Alberta. I'm back a ways. Rib Mountain, Wisconsin. Oh God, I just automatically scrolled to the. What else is new? Happy Valley. I'm done live now. Mount Shasta, California. Gunnison, Colorado. Derbyshire, UK. Crystal, Minnesota. Mankato, Minnesota. A lot of Gophers in the house today. Carthage, North Carolina. Gig Harbor, Washington. Honey Greg in East Tennessee. Ripon. That's John. Nampa, Idaho. Mount Ashland, Batholith. Lori is in the Klamath Mountains. San Diego, California. Rotterdam. Hello, Nina. No, Nina's, yeah, okay. Crescent City, California. Leamington Spa, UK. Murrumbina, Victoria, Australia, I think. East Lansing, Michigan. Webb Lake, Wisconsin. I see Stephen's in the green room. Can you hear me, Stephen? Okay, good. Wonderful. Alberta is representing. Denmark, Carlsbad, California, Stillaguamish. That's backcountry Gary. Hello, Gary. I'm going to need some help from you in the next couple weeks. I'll let you know. Michael and family from County Cook, Ireland. Hello, Michael and Nee. Good evening to you. Boxborough, Massachusetts, Klamath Falls, Oregon, plain old Seattle. That's backcountry Lindsay. I'm coming to you, Lindsay, as well. I'm going to need some help. Whatever. I'm going to try to feature some photos next month downtown. McKinney, Texas, Half Moon Bay, California. There's Karin. Can you hear me, Karin? Okay, good. Well, Basil always makes a late appearance, and so I won't be too worried yet. And if you guys want to share your screen now, go ahead if you like. Whatever floats your boat. Woodinville, Washington. Yeah, please. If I haven't seen you yet, where are you viewing from? We've got a few more minutes. Glasgow, Scotland. San Antonio, Texas. Don Pedro, California. Omak, Washington. Squaw Valley, California, Montreal, Sacramento, Quebec, Madras, Oregon, Concord, New Hampshire, Vinnie Northwest from Spokane. Oh, Philip in Sweden is a big fan of Karin. Oh, my. All right, tone it down, would you? Come on. Regine's in France. Saber from Baja, Mexico, on the beach. Good morning, Saber. I made the beach part up, but I like to imagine that, Saber. Still no Basil. Chicago, Illinois. Wenatchee, Washington. Hello, Richard. I'm not sure I know you. Elaine's in Tucson. Smyrna, Washington. Yeah, okay. So I think I want to announce this now just to kind of get it off my mind that these noon lectures on Friday continue. And on this YouTube channel, sporadically on Fridays for the rest of the school year, there will be some guest lectures giving talks. And I have you seen any of those? I'll be broadcasting those live, and I'll be hosting basically. Not me talking, but we have some interesting guests coming in. Hannah Shamlou and I have been putting a schedule together. So one of Hannah's friends, co-workers, igneous petrologist, Tyler, will be giving a talk this coming Friday, February 24th at noon. And the following Friday, a relative of Randy Lewis, John Schellenberger, Native American, who is part of CWU now, is the director of Native American Studies, and a former student of mine, by the way. John will be talking about indigenous landscapes here in Central Washington. So look for Friday talks throughout the rest of the year, and I will be able to have a little thumbnail, and you'll have some advance notice so you can set your notifications and everything. If you want to join us for those, that'll be fine. All right. Where the hell's Basil? That's a drinking game. Where the hell's Basil? A few more. Karin, did you get a second screen going? Are you set with that? Okay, good. Okay. Gerald is in Alabama, and Gary's in Sulphur, Oklahoma, and Larry is in Hebron, Kentucky, and Kirk is in Philomath, Oregon. Thank you, Kirk. Yeah, Mark, that's the next t-shirt. Where the hell's Basil? The absent-minded professor. Not really, but like he does kind of cut it close. We were testing the audio and video, all three of these guys, an hour ago, and Basil's like, yeah, I'm still at home. I got to get to school. And I'm like, oh, all right. He said, I think I need to shower first. So we may bring him in last because he may be appearing last in the green room. All right. We got 4 minutes. A few more final hellos, and then I need to start concentrating about today. Very much looking forward to today. New Mexico. Hello, Scott. How about a few more hellos to everybody, and then I'll start ramping up here. Elmo, Washington. I'm not sure where that is, Don. Ken is now at Sheridan, Wyoming, Winter Rodeo, watching. Okay, too much there, Ken. I can't follow. Bo is in Denmark, Fair Oaks, California, Bellevue, Washington, Beaverton, Oregon, Polson, Montana. That's Charles. Sammamish, Washington, Dorset, UK. Zazu is in Belgium. Selwood, Oregon, Marion, Virginia, Avondale, Arizona, Beaverton, Oregon, Morgan Hill, California. Yeah, I've noticed a bunch of you are like nostalgic and reflective in the chat. Like, wow, okay. I guess that's what you do when you're at the end of something, but kind of been fascinated reading your comments as I'm just kind of sitting here getting my stuff together before we started. So yeah, we'll close the series when we're done with our guests and talk about what's coming down the road. Hey, there he is. You made it. Hey, Basil. Okay, good. All right. Well, we got everybody in the green room. That's nice. Thank you for being here, viewers. And we will begin the program in 2 minutes. We have more than 600, and folks are continuing to roll in. I hope you enjoy this last show, Session Z. Hot mic. Hot mic. Okay. You're starting with the purpose of the show. The purpose, the goal. It's maybe not what everybody thinks. So be clear about the goal. What are we trying to do here today? You can do that, boy. You can do that. You go to the 2 chalkboards. Right, the short list of things that probably will be discussed. The short list. Go to the short list after the identifying the goal. Then Karin's chalkboard. Do it quickly, but also visually lay out everything you have on the chalkboard. Laptop to look at the papers very quickly, and then we go Karin first, Basil second, Stephen third. Is that what you're doing? Yeah, that's what you just, right. Karin first. And you got Basil's email. Okay. 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 I believe in you. You can do it. You can do it. I believe in you. You can do it. You can do it. Good morning, everybody, from Ellensburg, Washington, USA, home of Central Washington University. Thank you for being here for our last show. This is it, man. We're to Z. We're to Z. We're to the end of the alphabet, and we have a very special treat. By popular demand, we have 3 guests today who we already know from earlier letters in the alphabet. We know these folks. We don't have to start from scratch. But there is a goal today, and the goal is to sit around the campfire and listen. I'm talking about you, the viewer, and me, the host, or whatever I am. We're sitting around a campfire and we're listening to a geologic discussion. And I might pop in occasionally and steer things, or if it feels like, there's kind of a lull, I maybe interject a couple things here and there. But like we did in the last show, I want this to be kind of a free-flowing thing, and our guests are bright, they're nimble, they're well-respected, they have deep knowledge, they have not collaborated much with each other to this point, in print for sure, but maybe even just otherwise. And so I think they have been talking a little bit by email this week to kind of get a general idea about what they want to do, but I purposely didn't want to be part of that. I want to react to this just like you at home. I just want to listen in, mostly keep my mouth shut. And some of my most memorable, enjoyable geology discussions are out in the field, literally sitting at the campfire. Everybody's staring at the campfire and tossing stuff in, and sparks are flying, and you maybe having your favorite drink or whatever and eating some Doritos. I don't know. And just listening in on these kind of freewheeling discussions that have no rules, but everybody's listening to each other, and that's what we're doing here. I don't have to set the tone more than that. These guys have been watching the series. They know who I am. They know what this is about. They know this is not a rock fight. This is not a debate. This is not some sort of game show where we have a winner and a loser. That's not what this is, and you knew that coming into this. This is just a new way to talk about this sort of thing, and these three folks who are representing our three models that we've been talking about since the beginning of the year are here with us, and it will be fascinating to learn from them. So here we are once again. The majority opinion, we have no representative. The three alternative models, Basil is representing the hit and run model. Karin is representing the fixed archipelago. Stephen is representing the ribbon continent. Have there been other workers in these camps? Do they have close collaborators, loose collaborators, whatever? Sure. But just for simplicity today, I'm just going to go Basil, Karin, and Stephen. Those are our three guests, and that's what I want to do. And the expertise of Basil is the lower 48, the Rocky Mountains, the Sierra Nevada, the Western Idaho Shear Zone. We know all that. So his deep knowledge is mostly in the lower 48. Maybe I'm selling him short, but that's, I think, important to point out. Stephen is coming at us from deep knowledge, intimate knowledge, field geology knowledge from the Canadian Rockies, up into the Yukon, the Arctic, and Alberta and British Columbia Rocky Mountain geology. And he has confessed that once he gets south of the border and gets down here, he's less comfortable with what's going on. And Karin is an offshore person, meaning an ocean plates person. She's the lower mantle person. She's the person who's been doing this work down in the lower mantle from a physicist point of view and learning geology in her close collaboration with Mitch Mahalanuk, and I'm just stunned at how quickly she has kind of gotten herself into this world of tectonics and all these detailed discussions about these places. I don't even know if Karin's been out here very much, but she's really on top of her game. So we have three different models from three different points of view and expertise. And yeah, I'll say it, I guess, like over the last 50 years, when you get three different groups getting together, it doesn't go well typically. But it's going to go well today. The vibe is going to be different today. And we're going to have conflict. We're going to have disagreement, but it's done in the name of collaboration and new ideas and literally sparking new ideas and new collaborations perhaps. Okay, so that's the opening board. It's going away. I don't really know, but based on a little bit of the email stuff that I did see from these guys this week, I was copied occasionally on certain emails. We may, but not required, get in this neighborhood. You know, the title of this is Subduction Polarity. Now, I haven't used that phrase because I think it's a dumb phrase, personally. Subduction, we all know what that is. Doink, okay, ocean floors going down, diving down. That's Geology 101, we're fine. But polarity, subduction polarity, what is that, some sort of magnetism thing? Like North and South Pole polarity? No, it's got nothing to do with PaleoMag. Polarity like, oh, one group thinks this and the other group thinks that and they're opposite. No. What's subduction polarity? It's just like, are you dipping the ocean plate to the east or to the west? That's all that means. And that's the start of our session. The start of our session is thinking about ocean plates dipping east, where and when, dipping west, where and when, and thinking about that between the three models. There have to be some differences. I know there are some differences, but I'm very fuzzy on the details there. In addition to that, we may end up talking about ocean trenches. Which of them are fixed, and what evidence do we have for that? Which of the trenches are drifting through time as we drift a continent, and therefore the trench is drifting along with the continent? We may get into subduction complexes, I'm pretty sure we will, or accretionary wedges, in other words, a melange. We've talked about that concept a number of times. It's a chaotic mess typically, and is it so messy in those subduction complexes that we might be missing some ocean sutures in those accretionary wedges or those subduction complex, possibly even some Baja BC faults. Leave it alone. We'll see if it goes there. And then at least Karin and Basil, I think, are very interested in the foothills of the Sierra Nevada of California. And we've been flirting with it, but we might come back and hit it a little bit harder today and think about it. And all three of our guests have slides they want to share. They don't have 50 slides each, but they've got a handful of slides. And so we're going to get little mini lectures, I guess, from each of these three. And then, of course, we'll have this discussion as well. Final thing I want to do on the chalkboards and I did this last night. And it's almost certainly wrong. It's almost certainly wrong. But I think you know how I like to operate. I like to draw things out in a very simple form and then put it out there and then see how wrong I am. Hell, you can look at past episodes to see that this winter and even earlier than that. So from emails from Karin over the last couple of years, from reading the papers, and I haven't even double checked this with her or anybody else, this is what I think I understand about subduction polarity from the fixed archipelago group. From Karin. Older than 170 million years ago. And I'm just doing this as an accordion. Of course, we're not thinking about the symbols at all. I'm going to do this quick because we've been touching on these concepts for weeks now. Here's Old North America with a eastward dipping oceanic plate. Subduction polarity, I think according to Karin, we've got two separate eastward dipping ocean plates. This one beneath the Slide Mountain Ocean. And this ocean, older than 170 million years ago, is the body of water between Old North America and intermontane superterrane. This is Cache Creek in between Quinellia and Stikenia. And there's a volcanic arc above both of those eastward subducting oceanic plates. That's older than 170. So you're like right off the bat, like, wait, I thought she was the westward subduction person. Well, they do have westward subduction, but not during the whole time. I think I'm understanding that it's really only between 170 and 150 million years ago that there is good evidence from the fixed archipelago group, Karin, that we need westward subduction. I guess because we don't, no, I'll just say what the model says, I think. So we no longer have a volcanic arc in intermontane. We no longer have a volcanic arc in Old North America. And this model says that we have westward subduction underneath the Mescalera Ocean. And we have a volcanic arc on Insular out in the water, fixed. And we have eastward and westward subduction beneath this monster microcontinent out there known as the Insular Superterrane. Finish the story by getting, I guess, at 150. And you're like, this is way before Basil. Basil says, remember, hit and run is like 100 million years ago, the big hit, and then the run, 85 to 55. Look at these dates. Everything is earlier than 100 million years ago. So how important is this discussion to Basil's model? It may be relevant. So we're back to eastward subduction. I guess starting 150 million years ago, and a volcanic arc it sets up on Insular, which has already been accreted, according to Karin, and we've got eastward the rest of the time. Okay, I'm going to do it. Before I bring Karin in, I want to give you, again, to help set the tone of this. Basil didn't see this, but he saw the show with Karin and Mitch a month ago. And this is, I'm going to read you a portion of Basil's email to me, just me, January 21st. Nick, that was a really great show with Karin and Mitch. And actually the show with Randy Enkin was superb also. Nice job. I really want Karin's model to work. Okay, right off the bat, I'm in. This is not a rock fight. This is Basil Tikoff saying, I really want this model to work, if this is accurate. I really want Karin's model to work. It has a major problem, however. Their story works for the Jurassic. There was an arc in California. It does shut down. There is a suture. All of that is completed by 150 million years ago, no problems. This is Basil Tikoff talking. The problem comes in the early Cretaceous. The California Triad is a complete subduction complex. I would say definitely from 125 to 150, I would say definitely from 125 to 100 million years ago. Many people would say California Triad is a complete subduction story between 125 and 85. Most people would say until the San Andreas system starts at 18. So I think most people would say, this is Basil talking, most people would say eastward subduction would go from 125 million years ago until 20 million years ago in California. The point is, you cannot have insular or intermontane against Central California margin between 125 and 100. It's geologically impossible. You have blue schists of that age and a magmatic arc of that age in California. You have arc magmas in Idaho and Baja California too. You need, he's saying again, you need eastward subduction between 125 and 100 under Western US and Northern Mexico. I have thought about this long and hard, and it's really hard to get around this problem. But then he goes on. There are some ways around this issue. One way is to rift insular everywhere south of Idaho between 145 and 125 by subduction rollback or something like that. And there is no arc during that time. And then you can start pulling it back to North America, starting at 125 million years ago with eastward subduction under North America and have it collided 100 million years ago. The problem is, I don't think the tomography, the stuff in the lower mantle, of the slabs work in a way that could make that interpretation work, but maybe they do. And the other alternative is to just have their timing be wrong, and you can do that with some sort of mantle wind. And if you do, you only see the westward subduction under insular at 100 because the eastward subduction is happily under the Atlantic Ocean. No problem with the Jurassic because that stuff is long gone. So they can be correct if their geodynamics and their timing is wrong. It'd be nice if they were right about tomography and westward subduction under the insular terrain. We will see. All right, well, Basil, I hope you're okay me reading a personal email that you wrote, but I think it sets the tone of this perfectly. Like, okay, I'd kind of like this to work, but here are a couple things that I know in the lower 48 that don't quite make that a nice, easy solution to what I know. Okay, I'm getting the headphones. We're going to Karin first, and we might just bring everybody in right away. I don't know. Let's see how we feel here. Let's go to Karin Sigloch in the south of France. Good morning, Karin. How are you?
Hi, Nick. Good evening. It's good to be back.
I'm so grateful to you for coming back. It really is a thrill, and many people just said, we need her back. She's just so good, and that's true for all three of these people, so thank you. And I think the audio and video is looking great on my end. How about your end?
It's very good. Yeah, thanks.
Well, I think we'll just bring in everybody. Why don't we do that? Let's get Basil in next. Madison, Wisconsin. Basil, how's it going?
Still morning.
Still morning. Hey, time zones galore here, and you're looking pretty good and sounding pretty good as well. Are we doing okay there, Basil?
Yes.
Terrific. Okay, Edmonton, Alberta. Let's do it. Stephen Johnston, how are you?
I'm good. How are you, Nick?
I'm doing great. Thank you. Okay, I think we are totally functional. That's a relief. We have 4 people on screen. As you saw in the last show, you guys, I think we'll just keep mixing and matching and getting 2 people, 3 people, a shared screen coming in, whatever. I'll be the director of this production. Look, Karin, can I start with you? What did I screw up here glaringly with the elements of your model?
You did pretty well, especially as far as the contiguous 48 is concerned. I mean, in your middle panel, at 150 to 170, there's no eastward subduction under INS, not at that moment.
Oh, okay.
But we'll get to that. We'll still get enough time for Basil's Franciscan to form. So we'll look at that,
Okay.
but not from 100. Well, shortly after 150, I guess. You know, those old in your oldest panel, you should have asked Mitch that question. I think that subduction zone under North America, I mean, it should be like that under, certainly in Southwest US on the Craton, but I think in Canada it's probably in the other direction under Intermontane, but it really doesn't matter for us, and maybe you should ask Stephen. And and maybe the second eastward subduction doesn't exist, so I'm not sure, but it really doesn't matter. And then the bottom one is just fine. Yes, but I would like to say something. I mean, you know, anytime you draw such a 2D sketch, it applies to exactly one place, and that's why I'd like to show a map later of it. You can make any number of cuts, and any number of cuts you would have to draw a different picture, and that's where these confusions come in, right?
Yeah, that's the part of the challenge, isn't it? I mean, come on, you can't just pick one latitude and tell the whole story. And of course, we're getting there. Basil. At this level, at this first kind of pass, first of all, are you pissed because that I read your email? I hope not.
Watch out what you email Nick.
Yeah,
and
right.
that's my. Now I can think only of what am I going to, how I'm going to give an answer to Basil in this show.
So I think I want to try it right away, Basil, if you're okay. Like you don't see. You don't like anything parked off the coast of the California Triad during this time. Why not?
That's correct. That's correct. And Karin is exactly right, because the top cross section might apply in Idaho, but it doesn't apply in California. So that's part of the problem is, again, with the way I'm thinking about it, right? So these are my models, and so my way of thinking about it, Intermontane is never south of California, south of the Sierra Nevada.
Yeah. Well, right off the bat, let me say that let's pull back for a second. What am I doing? Like, this is a Baja BC final show, and we got nothing but Jurassic and Cretaceous. Like, does this even matter? Stephen, does this even matter to have this discussion if we're thinking about northward translation? Should we just get rid of this board and think about much younger stuff?
Oh, it's two-sided, as subduction often is. You can't get back to the Jurassic without first undoing the Cretaceous. But what happens in the Jurassic has got a huge impact on how we understand the Cordillera, because if you shuffle the deck in the Jurassic, then you don't have a template for undoing translations in the Cretaceous. So it's difficult. Yeah.
I'm feeling probably too free here at the moment, but I'm going to try one more thing, and then we'll decide who wants to share some slides first. Basil, you're pretty clear. Hit and run model. We've got northward translation between 85 and 55 million years ago. So I know where you stand.
It starts at 100, a little bit, but yes.
Okay. Stephen, I'm slightly confused on what you just said. Are you thinking about some northward translation earlier than that?
No, I'm not.
Okay.
No,
okay.
The Jurassic becomes important because of its implications for what's in the archipelago. So, you know, I tend to be a strong supporter of the of Karin's story with Mitch. I think it's the tomography and the story they've developed from the geology and the tomography together is extremely robust. I guess the only way where we differ is what's in the archipelago, whether it contains the intermontane and portions of what's called North America, or whether it's insular entirely, right? So, and the answer to that might lie in the Jurassic.
Huh. Okay. I guess we're still in the opening phase of this. Karin, anything to say? Who should go first, by the way, with their slides? Does it make sense? Have you guys decided what works there? Karin?
Let Karin go.
I wouldn't mind showing a busy slide, but you've educated your viewers for 3 years now, so maybe that's okay.
You know what? I want to say one more thing. So all three of you guys are leaning hard into the PaleoMag. All three of these models, I'm reminding the viewers, I guess, that we're not ignoring the PaleoMag. Basil and Stephen, for sure, like involved in that PaleoMag. Karin, not directly working with the PaleoMag. Is there anything, maybe I asked this a month ago, is there anything in the lower mantle that's helping you see that there's northward translation? Or was it mostly Mitch that said, look, we got to include this PaleoMag in our model?
Both. I mean, yes, there's direct. I mean, when we do these matches, you know, there is a slab, so that means you have to have had an arc. And so then you have to ask which terrain that had an arc has to sit over this slab. So once you've decided that, so this is insular and North America comes along, and because you have a reconstruction of how the Atlantic opened, it'll hit at a certain place. And in this, it hits in the US, but insular terrain, super terrain, this is its northern part, and then it goes south. This is the southern, right? So its northernmost part hits in the US. According to these geophysical and plate kinematic considerations, no geology in there. But today it is obviously not in the US. It's in BC and it's in Alaska.
Yeah.
So
Thank you.
It confirms, it's consistent with what PaleoMag says.
Okay, I'm getting greedy now. I want to do one more and then we're definitely going to Karin's slides. Do we need all these plutons to be tied to subduction? What do we think about this slab failure thing, which is a whole nother way to create this magma? Anybody want to just comment on that? Like, you're a huge believer, you don't see it working in your model. I kind of forget half about this slab failure mechanism. Basil, you want to try?
Sure. So many granites are a result of subduction zone, but some granites are not a result of subduction zones. And we can see them when they're obviously, yes, subduction zones, and we can see them when they're obviously not, like the Tumica granite belt. But then the slab break-off type plutons, which is not quite the right name, but it's possibly correct. It's a really useful insight that Bob and Wayland had about how those plutons work. The petrologists argue about them a lot, about whether you can use those kind of chemical discrimination plots to say definitely yes or definitely no, and that is beyond my ability to evaluate. To me,
Sure.
It seems reasonable when you plot them in the areas that I know. It actually makes a lot of sense. So again, from a very empirical point of view, there's likely something to it.
How about you, Stephen?
The issue is, like, everybody has little bits of contribution. Like, we're all trying to, like, keep up with, like, the new data as it comes in.
Yeah, I'd just add, if we knew what plutons were definitely arc-related plutons, the source being subduction, this debate would be over pretty quickly. Like, I think, and specifically, you know, I look at the, and I'll talk a little bit later on about the Omanika magmatic belt,
Right.
which I think is a product of subduction. Most people don't. and I'll explain why. But yeah, as Basil says, the tectonic discrimination plots don't yield unique answers.
Huh.
So.
Got that. Okay. Well, I think we've done it. I think we've all whetted our appetites to look at some of these slides. So that was a weird way to like pat my own back. All right. So Karin, let's bring you in. Hey, looking good. Full screen, everything. Please proceed, Karin. Thank you.
Can you see my cursor on this slide?
We sure can this year.
Oh.
What an improvement. Yes. Perfect.
Okay. Okay. So yes, I mean, this is a busy plot, but it's because you asked, where was the subduction over time? So I have plotted all the trenches in the whole archipelago over time. And it has the same kind of rainbow color scale that you've seen previously when we've done 3D renderings of slabs. So a color is a certain depth, and if it's red, then it's the deepest depth. So if you just tune your eyes into the red shades, that's the deepest slabs, and the bluish is the shallowest, and in between the colors. And you can see this. The scale here, which really what is plotted is depth. But then, in order to do anything with this, we have to convert it to time somehow. And we're doing this under a hypothesis. And so the hypothesis is that the lithosphere, the subducted lithosphere that we image, is still in the place where it sank. So that's it sank vertically in the mantle. So plus minus a few hundred kilometers. Okay. And the other thing is that if we see it at the same depth, so if we see a red one here and a red one here, they entered the mantle at the same time. Okay. And so we're going to use that as a hypothesis to make predictions. A hypothesis means it's an idea, and you're going to see if it works, and you're ready to reject it if it doesn't work. Okay. What we're not doing is saying we know how fast these sank. So that's a question where we're going to, for each of these stripes, for each of these depths, going to estimate from the data, from the observations, at what time they entered the trench. And I can explain that a little bit. I will explain it a little bit. I just for you to know, the end result is that it doesn't matter with which color you do this. The result was always it sank at a rate of about 10 millimeters per year. So it turns out it seems to be a very uniform sinking rate, and the number is 10 millimeters per year. But this is not something we assumed. It's something that comes out of these geometries. Else it doesn't. It's the only number that makes sense, so to speak. Okay. But now if we look, we take a step back. So where do you see red trenches, the old ones? It's here and here and here. And you can also see that the next colors, the orange and the yellow, so the next younger ones, shallower ones, are all clustered in the same place. So those were the slab walls. Right? So it's all in the same place. But there's some other places where we see red trenches, and they're here. Even redder, even deeper red is here. So we had something that was oriented like this and then broke up into two that looked like this. And there's also some down here. Okay, so then all these red represent the trenches of old times. And the one that we've been talking about most, and that you also summed up here, is a section that goes like this. Right? This is the section that is the US section, basically. And so if we look at that section, we have this deep slab wall that doesn't move. And then here's North America, just when the Atlantic starts to open at 170 million years, which is this time. Until that time, there was an arc here and subduction in this direction, so under North America. But that stops now. And there's also no more slabs imaged under this place. Okay, and so now you have to ask, okay, what happens? North America, we know it. So now my cursor is gone. Sorry, I have to find it again. Here we go. Can you see it?
Yes.
Okay. North America will do this. So the green version of it is 80 million years. That's roughly the Baja time, and the gray one is today. Okay, so that's the journey it did. In order to be able to do that, well, this lithosphere has to disappear. We've talked about that, and the only place it can disappear into is this. And so that's what it does, and it reaches this place about 150. And so that's when it collides with an arc here, which we say then is insular, because insular is the terrain that had a Cretaceous or Jurassic and Cretaceous arc. So now my cursor's gone again, sorry. Here. And we see that this slab is changing as it shallows, and it looks as if it's being pushed, right? It's getting shorter and it's getting pushed to the trench is retreating. And it's actually not being replaced in this place, really. What's happening is we now see, as we go further east, there's younger slab, and it's also now it's a trench that is moving. It's moving eastward. So what if we imagine now that we're at the point where the continental margin is like this, right? So what's happening? It's already overridden some trench here, so there's no more lithosphere of westward subduction to be subducted here. That must have stopped. There is still an open ocean here, right? So under Mexico, there's still this westward convergence going on. But here, if the margin was here like this, no more westward subduction. But there's always lithosphere sitting at the surface of the Earth. And as long as the continent will keep moving, that lithosphere now here, that has to disappear. So the only way this can disappear is under the margin of North America. So that's when it flips to eastward subduction. And this is marked SN for Sierra Nevada. So that's when we say, okay, it's forcing now a flip in this place, not up here, still westward subduction, not up there, still westward subduction. But in this place, it's now has forced a flip, and it's starting to build the Franciscan, or it's doing the plutons of the Sierra Nevada, and it's building an accretionary complex. Basil, we're not totally sure this is the Franciscan because of the Baja BC shearing, but it can be the Franciscan. But there's another candidate. Okay, So Nick, that's the section you drew, and that is the case. But it's very important to keep in mind that up here there's still slab pulling into this trench westward. Here's slab pulling into that trench. And it's also important geophysically because we know that slab pull is what moves the continents. So we still need a motivating force to keep North America moving, because this one wouldn't do it. But of course, as it continues, and you can see here at 80 million years that its continental outline, it's still actually no. If we added the Mexican blocks, subduction here would also be over westward, and it would have forced an eastward flip. Farallon. Up here, there's still a little bit of, that is Stephen's terrain wreck here, which is just a beautiful fit with this slab. There's still a bit of westward subduction. But as North America goes on, it forces a flip everywhere here. Okay, and so it all becomes eastward. And that's not all, though. We have not talked about these deep ones that are just the same age as these old ones in the east. And so what's this then? Well, that has to be Farallon subduction. We know that there's a little Farallon plate growing from this place. We know it's spreading towards the east. And we know it has that age of 180 or even a bit older. So we need a slab for it. And this is the closest slab. And actually, it's still subducting into the slab. So you can see that these colors are going all the way up to the surface. And that's the Cascades arc where you are. So that for sure is Farallon. This one is also has to be Farallon. If we look at how the seafloor isochrons grew, it's a little younger. But Basil, we think, this is another candidate to grow at least parts of the Franciscan subduction complex if that gets sheared. And we know there are large PaleoMag displacements. And so this is related to the Alicitos terrain. And so that means, it's really two big oceans that are subducting. I mean, the Farallon is still subducting, and that Mescalera one was subducting for a long time. Just not in California. In California, it was the shortest little, it was from 170 to 150, which makes it so hard to resolve there.
So I'm going to interrupt just a second. This is beautiful. That's a figure I hadn't seen before. It's like really exciting. I'm probably jumping the gun, but like, Basil, you keep talking about this massive collision at 100 million years ago. And Karin, I'm losing track of time a little bit on that slide. Can we go back to it and like, where is Basil's big hit 100 million years ago? What on this figure indicates what's doing what at 100 million years ago?
Yeah, I mean, at 100 million years ago, the margin would maybe have been roughly here. And so, I mean, that's probably the point that we differ most from Basil, because we don't perceive, in this scenario there's not an obvious reason why 100 million years should be very different from 110 or 90 or 120, because once North America enters this slabscape here, it just gets in contact with more and more. First it's just here, then it's all this, then it's all that, and then the northern one joins. And from our reading of the geologic record, it also seems that there's at least a large body of literature that suggests it starts in the latest Cretaceous or earliest Jurassic with the Sierra Nevada orogeny and the passage beds in Canada, and then just continues uninterrupted. But that is I guess our main difference with Basil.
Basil, any reaction to that? You're muted right now, by the way.
No, I mean, it's good stuff. It's great stuff because it's a whole new data set that we haven't had. And the idea that it has to be westward subduction is pretty compelling. The geometries that Karin has laid out make that really kind of work. I mean, it's interesting. The problem is, so because I'm not looking at slabs, I'm actually coming at it completely from the other side and looking at it from North America and saying, what's going on in North America? The Jurassic is just not that big a deal. I mean, that's the first of the foreland. We get the Morrison Formation. There is a Nevada orogeny. It affects unequally things up and down the coast. It's we see it in the foothills and we see it in Death Valley. But there's no ambiguity that the big collision is the severe fold and thrust belt. And what structural geology and sedimentology are great at is timing, right? This is the thing that we knock out of the park. We can tell you exactly when these things are happening. And the timing, it's starting at 125. That's more localized. It's more only in northern Nevada. And then the system goes crazy at 100. And so again, it's not a preconception that it has to be 100. The data is telling you something's happening at 100. And so in the same way, it's data. The data is driving the model. And I think that's also true with Karin, that the data is driving the model, but they're at odds with each other a little bit.
I mean, it'd be nice if Karin's image we were just looking at had evidence of we stop a fixed trench and we start drifting it at 100 million years ago, right? Would that be the ideal scenario?
We're done, right? That would be great. But again, the data say what the data say, so we have to sort of figure out what is the mismatch.
Well,
Karin.
Yeah, I mean that the Nevada orogeny is a localized hit. That fits us perfectly, because the first hit is just with a little promontory of slab that sticks out eastward, and so it takes a few tens of millions of years to make more contact with a longer and longer line of trench, or accreted insular. That is, it slowly plucks insular off its trench, And so it's possible, I mean, that there is something, that is beyond the resolution of this lab or our reading, our understanding of how to read it. Maybe there is something in those geometries that show that something is stuck at, gets stuck at 100 million years or so. But I mean, also, if you say it starts at 125, that makes it already much more compatible, right? Because then we're just talking a difference of about 20 million years or so. If you say the Sierra Nevada orogeny is another, well, but you say it's there. So, and I'm saying it's good if it's localized. And so maybe then that discussion is more about 140, 130. Where we think in the literature, there's also some debate of, how big or not. I reread Dickens in 2008 yesterday, and he seems to be unclear about this.
So Karin is exactly right that the Nevadan is much more a long strike. We see it in many places along strike. I was arguing not so much for its north-south extent as its east-west extent. It doesn't get strongly into North America. The prong is also a really interesting point. And with the possible exception of Idaho, there's really no evidence for like something kind of sticking out. It actually would work really well in that area, but it would have to be younger, right? Because the Idaho segment is where North America gets pushed the furthest in some sense. So that could work. I do want to get back to a timing issue, though, which is, and I'm not saying it's right, but if you look, the data is compelling in the Sierra Nevada that there is subduction that starts at 180 and goes pretty firmly to 100. And that data is twofold, which is what makes it compelling. One is, and this is Sean Mulcahy's work, shows that you start to get amphibolites followed by eclogites followed by blueschsts, all starting at 180 and moving down. And that's the evidence of a subduction zone. And there is, at the same time, the Sierra Nevada arc is active 180 to 150. So we see plutons, and they intrude a terrain in the northern Sierra. They intrude accreted material, but that same arc intrudes unambiguously North American material in the southern Sierra. So it's right along a line, but in the north it's accreted, and in the south it's North America. And if you have both the Franciscan evidence of a subduction zone and the arc, it's pretty hard to get around an eastward subduction starting that early. Now, could you say the subduction went the other way and then get plastered on? You can make those sort of models for that. But I think, again, most Western United States geologists would say there's probably pretty continuous eastward subduction starting at 180. So
is California out in the water at that time, or you're talking about old North America 180 million years ago?
This might be a Stephen question. I think most people who work in California want it happily attached to the continent, but that is an assumption. Stephen?
Yeah, I'll start by just going back to the 100 MA event, the severe, which in Canada we tend to call the Columbian, or used to. It is a huge event. It's the source of all of the thrust faults, for example, in Selwyn Basin, the Brooks Range. That's the main event in the Brooks Range. There's a younger event in the Brooks, but the severe event is pretty stunning. And so I agree with that. I come back to this whole thing about Karin made the point, you have to look at a map as well as cross sections. You'll remember that I said that we've got these clockwise rotations throughout the Cordillera, and when we look at the declination data, it's possible to have an arc that is North American in the south that, like today's Aleutians, runs off into the ocean at a high angle to North American. Some of Karin's tomography points in that direction, that thing can then rotate, right? And so you can move things north and have what is North American in the south looks totally oceanic in the north.
I mean, I think, Basil, that in the beginning the deformation doesn't reach very far inland. That seems almost expected because it's the first hit of not very much insular yet, and it's also still loosely. I mean, it takes a while to really couple, but as more and more gets slammed into the margin, and you still have pull from two sides, where now you're pushing as well from the eastern side. I mean, so it takes a few tens of millions of years to really consolidate and give a hit, so that it becomes more and more is part of what we say, but that it suddenly becomes much more at 100, that is not something we can read from the slabs, but we don't doubt. I just, I mean, this is getting very specific now, but I just wanted to say that we looked at the Sierra Nevada plutons around the time between 200 and 140 or so, and the ones that we need to be on the other side of the interpreted suture seem to be where they have to be, but I don't know, this is getting a bit very geeky here.
No. I kind of like this, like almost, I don't know, what do you guys think about this? We're kind of in the hit phase, to use Basil's model terminology. So we're thinking about closing oceans, we're thinking about subduction polarity, and we're bringing these things in, or we're going out to them, or whatever. Can we keep in this? I like specific, zooming out, zooming back in, and then at some point we'll kind of transition to some running and having stuff go up,
Okay, then I'd like to show
Good.
my Sierra Nevada plot, please.
Let's do it.
Is this still shared? Oh, no. Okay.
Maybe you need to share it again, Karin. I don't see it anymore. This is a blast. Viewers, I have no idea where you are on this, but and we're coming to you, but I don't think we're coming soon. This is too good. No offense. All right, Karin.
So this is a map of California, the Sierra Nevada here. All these light green plot dots are plutons, and also the little important ones are the red ones. Those are also plutons, and the most important ones are the orange ones. And the reason is that we have a slab that reaches from the slabs predict a suture in our view of things that runs from Alaska to Mexico and then actually beyond there, but okay. And so in California, it has to run through the Calaveras melange belt, which is between the purple and the orange lines here. And so these are base maps of Dickinson, and then in Klamath, it's an analogous situation. And so what's the prediction of? So I'm just going to now show just so you can see it's still the same slide, but now only this the Sierra Nevada. This is the Great Valley, and here are the foothills. And now we're just going to look at only those plutons. And what's the prediction of this westward hypothesis that we have here? Well, we're saying there was a short period in California, period of westward subduction, and it was from roughly when the native arc shut down, so about 170. That's the Mescalera subduction, that's this, going under insular, which would have been here, which is the Sierra Nevada foothills, a last little scrap that's left of insular. And that stops around 150 because that's when the first hit occurs, the Nevadan orogeny. Okay, so our prediction is that while the Mescalera Ocean subducted westward, so this is now the remnant of the Mescalera Ocean, this little in-between zone, right? Now, it probably didn't start subducting at 170 westward, it's probably more like 190 or so. So we expect plutons on this side and only on this side. Well, on this side of the suture during that period. So starting in maybe 190, something like that. Certainly then at 170 and maybe reaching until 150 or something. And then there shouldn't be any more plutons on the western side, because then we have this forced subduction flip, and subduction will go to the east. So that's the big phase of Sierra Nevada batholith. Now, Basil already explained this complication that before 170, there was another arc on North America, which is the native Triassic arc. So we can expect, and so we know there are plutons from that old native arc on this side. Well, or a bit, they could be anywhere, but they are predicted on this side. And then after 120, or well, after the flip, say after sometime after 150, they should only be on this side again. Okay. And so we colored these plutons by age. And if we go, and it's best to explain this with the most recent ones. Okay, there's this phase, which is the eastward phase that everybody knows about. That's the big classic phase, and that we agree with. That's after subduction flip. So they can be a bit on both sides of the suture because the two terrains were fused at that point. So we cannot say if they were east or west. We're happy with either. And you can see the green ones, the light green ones, they plot on both sides. The crucial phase is the orange one, because this is the one, the plutons that should be from westward subduction, and only from westward subduction, because the native arc had already shut down. By 170, there's no native arc. There can be a bit post-subduction magmatism, so we have to give it 5 or 10 million years. So we say, well, between 160 or 165, and then Sierra Nevada orogeny is 155, 150, there should be no orange plutons on the other side. There should be no orange plutons here. That would be against the hypothesis. And well, we don't find any actually, but you can see it's a very narrow, it is really pushing the resolution of dating here. That's the problem in California, not in Mexico or Alaska, where the westward subduction was much longer. Well, and then there is a phase where there were probably a little short phase of old mescalera subduction westward, and the native arc was still subducting eastward. So that's again not discriminative, and then discriminating between the hypotheses. And then there's really old plutons, they are native arc, and they should not be on the western side. They should be only eastward. And so these are again important, and they are only on the eastern side. So that's about Basil, your concern, or well, your assertion that subduction was always westward from 100 to 180. This Pluton distribution is permissive of what you say, but it's more suggestive of a short hiatus of eastward subduction and can accommodate westward subduction.
I'm going to jump in real quick and say that Stephen, I thought, made the point a few shows ago, like he sees the Sierra Nevada continuing up to the Omanika, and in between those two places is Basil's Western Idaho shear zone, like what we were just looking at in California. You guys, how much are you seeing? Do you see a similar story in points north?
Basil, this is you to start, and then we'll keep going north.
If you go just to Idaho, there seems to be an arc that's 125 to 100, and then the Western Idaho shear zone really kicks on at approximately 100. So into Idaho, it makes sense. And in Idaho, we're always looking at the Omanika to say, seems kind of similar, but I'd like to hear Stephen decide if that's true or not.
You want me to share a slide here?
That'd be great. Let me bring you in.
Okay, let me just...
God, this is fun. God dang, man, this is fun. Holy cow.
Okay, so this is a map of Yukon, Northwest Territories to the east of it, Alaska to the west. And what we're showing here is the distribution of mid-Cretaceous plutons. So, and these plutons cover the ages just discussed. The oldest would be about 125. They young all the way up to about 95, and some are even a little bit younger than that. And the interesting thing is that it starts off in these red colors, being good-looking arc. So magnetite-bearing granite diorites and diorites. And what happens is the rocks, these plutons, get younger to the east. So as we go to the east, we go from, older than 110, 125 to 110, to rocks that are 105 to 95. And that change in age is accompanied by a change in the nature of the magmatism. So it goes from these, what we call good I-type plutons, to more of what Basil was saying about 2 mica S-type plutons. And it's a gradational thing, though, because we go from magnetite to, in these light purple ones, to mixed kind of magnetite and ilmenite bearing plutons. And then the S-types are these good ilmenite bearing plutons that lack magnetite. And so that's just reflecting the degree of oxidation. In other words, the amount of sediment involved that's being melted to produce these plutons. So you have this beautiful west to east younging and a change from magnetite to ilmenite bearing plutons. And Basil, I seem to think you had that magnetite to ilmenite boundary map near Idaho as well.
It's you could tell the same story with a different map.
Yeah. So this black line is that boundary at about 110 MA between good arc and then mixed arc and sediment, and then totally sediment. And this is a map done by Craig Hart and colleagues. And their line, this what we'll call the 110 MA line, runs through Alaska and defines the big Z, right? The oroclines in Alaska. Okay, so how to explain this? To me, this is kind of a classic arc subduction zone complex that swallows a passive margin. So you get a nice arc. It youngs to the east because when you have subduction and you're adding material to the upper plate, this is an idea John Aldau promoted. He referred to it as orogenic float. As you're adding to the upper plate will grow towards the ocean. So this younging to the east suggests that the ocean was to the east for this arc. And the change as you go east from arcs to sediment is actually the record of swallowing probably the North American passive margin in that subduction zone. So this is the same arc all the way down through what Basil's been mapping in Idaho, and I think down into the Sierra Nevadas. But we have this very nice, not terribly squashed sequence that suggests strongly that the ocean was to the east.
But Stephen, that is the our Angayuchum Ocean, isn't it? I mean, so it's not. It's the Mescalera Ocean, but it's the northern half of it. No.
Yeah, I mean,
and it's to the east.
So I'm happy to put this entirely in the archipelago and find a way to make this fit with the slab. Absolutely. So is it Angayuchan, Mescalera? Yeah, it is, but it precisely where is the hard part?
Well, it's southwestward subduction, right? According to the tomography. I mean, I think the Alaskan orocline and the terrain wreck. I mean, that's really one of the most satisfying fits with this tomography because it doesn't have those are Cretaceous arcs, but they have no. In the literature, you find, I mean, they're just somehow they come out of the nowhere, or they're floating, they're free floating somehow in space. And but in the mantle, there's this huge slab, which is just perfect for slowly scooping them up. And I think that seemed unproblematic to me. That's not like insular. I don't know.
So the problem is when you take those arcs and you run them to the U.S., there's again, the U.S. interpretation is that it's eastward subduction getting younger. And the reason the argument is more tractable there is the youngest ones hit North America. They unambiguously intrude North America, both their isotopes and the wall rocks they intrude. So again, trying to be open, it's possible, but that's the classic interpretation.
You're talking about the Alaskan arcs, but the ones that go down the...
Well, it's really a
southwest.
125 to 95 set of magmas where the western ones are more arc related, and then they get more ilmenite to mica, so more sedimentary contaminated source. But what's interesting is, right, it looks like at 125, everything's kind of normal. I mean, it's just like, you can make it like it's all the same thing up and down the margin at that time. And that's, again, what the data say, and you have to pull everything back, but it's possible that all works out.
Well, let me try at this point. Yeah, I think we will eventually kind of start talking about some translation and anything else you guys want to do. We're kind of flirting with it right now, actually, because I'm catching myself in the moment, like, oh yeah, let's go up to Yukon with Steven. Oh no, shit, that stuff was down here or whatever. Like we can't just use the present day latitude, but it might be helpful just to pause and go, okay, I'm hearing both Steven and Karin liking a fair amount out in the ocean with westward subduction, and Basil talking about eastward subduction that we need at a certain time. But Basil, you're fine with westward subduction also. Don't you have that in your new paper that you've got? We're closing the Mescalera by subducting on both sides. Is that true?
The problem, and Eldridge Moore said this beautifully. He said the problem with the slabs that you see from tomography is that they don't have names on them. And what he was saying was,
dates.
Exactly. You have to interpret which they are and what the time is. And to do that, you have to take a model. So the slab that's under the East Coast was interpreted to be the Farallon shallow slab by Liu et al. In 2010 that doesn't start till 80 million years. And I like Karin's interpretation better, but the point is, it shows you the latitude in what you would choose to, how you would choose to interpret them. So,
okay, how about one more? So I see, thank you for that. So I kind of see Karin and Steven on the left side being more out there in the water. And then the other thing I think I'm hearing is that Steven and Basil are similar with some of this on-land timing and bedrock geology, and Karin's off by a few tens of millions of years. And that's maybe not the right way to say it, but like that's a hurdle, working with the time, the time. We're off by a bunch of time, it seems, the timing of this.
Well, but it seems to depend a little on which geologist you ask, if they consider there had to have been significant deformation from 155 onwards or not.
Okay.
So the one I talk to most is happy with the amount of deformation.
I think that's right, and I think it's an honest disagreement. It's whether you're in Canada and whether you're in the Western U.S., and I think they're fundamentally different in those two places. It's this 3D. And then the problem is, well, the Canadian rocks further south, right? So you've got that burden on you too. So you have to put the puzzle back together it's a really complicated problem. And Steven said this beautifully in an email, which was, if the standard model doesn't have any of these problems, because it's just like everything's happening in place, we don't need to worry about it. But as soon as you deal with the paleomagnetic data, you have to start making some very complicated and difficult decisions and models about how this could work. It's more scientifically valid, it's more satisfactory, but you have to start looking much broader at what you're doing. You have to take in stuff that you haven't seen, and it just makes it a much tougher nut to crack.
But even
Well,
even from the geologic side, the standard model, stuff just happens, right? I mean, there's 200 million years of Farallon subduction, and there's this incredibly varied geologic history over North America, and these different orogenies and different styles at different times. And there's no motivating force. What's actually worse is there's no slab pull, which we know drives 90% of today's plate motion. I mean, 90% of today's plate motion you predict by slab pull. There's zero slab pull in the standard model. I mean, it's not like it doesn't have any problem. So I don't think that PaleoMag is the thing that introduces the problems. I think they are there in the standard model. And at least, if you have, I mean, we're disagreeing over what hits or what collider makes a serious hit or not, but at least we have colliders, right? I mean, they are accreted by slab pull, at least in some views.
So Nick, can I show just a couple slides from California, sort of for the more sort of North American focused out version?
Absolutely.
Just to say that's what we have. All right. Let me see.
I think hit the full screen with the icon next to it, Basil.
All right. If I go full screen, I'm going to go blind, but that's fine. Here we go. So actually, I don't need to show this, I don't think, except to thank a couple people for helping me get some slides together. So the problem with the Jurassic or any older mountain belt is you have to pull things back to where they actually belonged at some certain point, and everything involved with that is an interpretation. The Jurassic's a problem because you have to look through this Cretaceous. And so what we're sure about is that there has to be slip along the arcs. It's about 400 kilometers. So that moves the Blue Mountains, which is probably Intermontane south. All of the Klamath and the Sierra have to move south about 400 kilometers because of the Cretaceous, and then another couple hundred because of recent sort of Miocene to present motion. And then, of course, the stuff outside San Andreas has to pull down even further because of that. So you have to, in your mind, kind of pull that down. And the reason this is so important is then you take the Intermontane, which is, my pointer is not working with you guys. Let's see if I can do this.
There we go.
Yep.
Got it. Yep.
So this Intermontane bit up here will fit happily back here and match the paleomagnetic data. If you do take all of this back, this fits very nicely, and then we'll move it's 1,100 kilometers north. So that's kind of compelling that the Intermontane never goes south of here. And the reason it doesn't go south is because the continent is bending out here. So it's kind of getting stuck. Then to think about the magmatic arc, again, from the California point of view, and Karin's right, so you have all this green Jurassic in the Northwest, but you've got it also in the Southeast, and these are the same age plutons. The middle plot shows the age distribution of those pluton. It looks like there's a huge amount more in the detrital record, so in sediments, but there's also a good record, and they seem like it's happening. And so if that's true, that's why I think people are calling on eastward subduction in the Jurassic between this 180 to 150, because you do have an arc. And then on top of that, if you look at the Franciscan, so you're out in San Francisco, and this is recent data by Mulcahy, and you look just at the ages of amphibolites, eclogites, and blueschist. So these are things that must be in subduction zone. It's pretty clear down to about 100, and then there's a couple dribbles after 110 or so. There's actually a new study that really pulls it down to about 100 by Apen et al. And you're stuck with this then because it seems like there's continuous blue schist facies deformation, the ages seem to be tied pretty well to this arc that are coming out of. And so once again, it argues for a sort of a different way of thinking about it. So the one thing I wanted to show was this Todd-Lamaskin slide, because what I liked about it, and this is why I asked him to show that, is that you do have these arcs. Stachynia does come crashing in. So Stachynia, Quinellia, this is intermontane, but it's all north of the Klamaths. And it sort of stops north of the Klamaths, and we have no evidence it was ever south of the Klamath. And that would do some kind of rollback, because again, you have to have continuous subduction, but it allows you to open up an ocean basin behind that, which is called the Coast Range ophiolite. And so the idea would be that the intermontane is either hitting exclusively north, or it just can't get by the little bend out in the continent. So again, it's not to say that it's right. It's just to say that there are other models, and the models are trying to explain, trying to use the fact that there must be subduction to drive this, to explain why that is the way it is. So that's sort of where I want to stop, just to say that there's different models for how you do it, and they're based on reasonable data. And there's right. And so what we need to do is like have the talk between like what's actually permissive, right? Like if that's really the data, what is a permissive model? And it might not be your favorite model, but it might be, but it's okay, right? It's actually within the range of the possible.
Thank you for that. How about a couple handful of more questions, maybe quick, I don't know, between the four of us, and then viewers, we're coming to you, and that will kick us into some other areas. But how about this? I wrote down a couple more. Is it open ocean offshore during Baja BC time? Or is there anything still out there?
In my opinion, it has to be against North America by 85 at absolute latest, because you're getting the Nanaimo sediments, but a bunch of other stuff that suggests the insular is adjacent to North America.
Yes, the insular has been adjacent to North America at that time for quite a while. However, your Cascades arc is slowly accreting now. It's finished by 55 or 50, but it probably makes first sort of slow contact around 90 or 85. So in our world, the whole Baja BC train wiggles through, well, along the margin, but still inboard of the Cascades arc, which is the last thing to accrete. So that would be the Pacific Rim subduction complex.
So you do have an island arc out there in the water, Karin.
The Farallon, the Farallon that we know, the northern Farallon, the most oldest part of the Farallon accretes the last, yeah.
Huh. And Stephen, I mean, you had intermontane out in the water with the Yellowstone mantle plume at 70. I mean, is it appropriate to bring the Carmax in right now to help us with this question?
Sure. I'd say to Basil that you can provide those North American zircons if they're in the ribbon continent, right? If you've got a substantial whack of what probably originated as North American continental crust along the eastern side of the ribbon continent, you can, and that would include, the Belt Purcell. You can have that whole thing offshore and still be providing North American zircons to the Nanaimo Basin. So I tend to think that the ribbon continent had to be very close, but certainly in parts was still not North America. It was still separated by a basinal tract. And you still get in the Alberta Basin, if you look at the stratigraphy through the latest Cretaceous, 85 to 60, it's chock full of volcanic ash. And that volcanic ash is probably a record of subduction of that proximal but narrow basin.
Karin.
I just also, then I guess I also would like to say something about these old North American zircons, because it seemed that end up on insula or next to insula. And that seems to have been the main, or one of the main objections against archipelago type models since Eldridge Moore, is that if you have an offshore arc, you should not have a lot of North American old zircons in there. But that is not a valid argument, because if you have westward subduction, so under the continent, and North America is here, you just have to drop something in the ocean right off the margin and wait until that conveyor belt brings the stuff to the accretionary complex, which is the suture. And so the argument that you should not have those then in the subduction complex and spilling over, and that's just not a valid argument. I think that I don't know, that something seems to have gotten muddled there. And so Mitch last time showed the analog of Australian shedding into the northward subduction ocean and totally flooding the Banda Arc, and the arc is already sitting on that accreted stuff from Australia. So it's an island arc sitting on Australian debris. So yeah, I mean that argument doesn't seem to be right against archipelago.
This is just so great. I mean, come on, viewers, go ahead with your caps lock, put your questions in, and while you're doing that, let me try one more for all three of these guys. Recently, in a few letters, we were way the hell east looking for major faults and having translation north. I'm starting to drift back a little bit west and think about Churn Creek and places that are a little bit closer to my backyard. Any comments from any of you about looking in a subduction complex or looking in the Cache Creek or wherever for important places in this Baja BC discussion? Or not?
Well, I mean, what Stephen said about the ribbon continent is true. If you take, in fact, you don't have to take North America. You have to take Idaho, because that's where these things are coming from. I mean, that's the only source we know. There could be a Mojave source, but right now, the only source of the 138s that seem to be getting in there are Idaho. So you can do that, and you do solve both the PaleoMag problem and the detrital zircon problem pretty well. The problem is you have to have a structure to the east, and it's kind of problematic where to run that in at least the Western United States. I mean, we've heard the arguments in Canada that maybe there is and maybe there isn't a place, but in the U.S. West, it's really tough to find the place that you could put that. But what I like is, like, everything's open right now. It's just like, let's just try and figure something out.
Yeah.
Can I follow up on that with a slide?
Good, you bet.
Are we on here? Okay, let's just do this.
Thank you, Stephen.
So this is a terrible figure for a presentation, but it's from a nice paper by Harry Vandervelden and Fred Cook, who were at University of Calgary. And what it shows up top here is a geological map right along the 49th parallel in all of these terrible shades of gray. But the only thing you need to point out is this is the Rocky Mountains. This batch in here is our Belt Purcell. Okay, carried on a major thrust fault that we call the Lewis. And this is the Rocky Mountain Trench we've talked about out here. So here's they have a beautiful cross section of across this map here. And and it's constrained by seismic, reflection seismic, as well as numerous wells that have been drilled through here. So in essence, you've got the belt Purcell carried on the Lewis thrust sheet, and the thrust sheet and all of this is pushed back on top of North America, right? So the gray down here is the Precambrian Canadian shield, right? It's 1.8 billion year old and older basement rocks, and all of this is the stratigraphy that has been used to say it's nailed to the continent, right?
Mm-hmm.
So if we go down and look at it simplified down here, and then what this is down here is a palinspastic restoration. So they've undone the displacements on all these faults. This vertical hatch right here is the belt Purcell, okay? And this line right here is the Lewis thrust sheet, okay? And you can follow it all the way up here. And so when displacement takes place on that Lewis thrust, this is what you end up with, right? This line here gets shortened all the way to here, and here's the Lewis thrust carrying the belt Purcell and its hanging wall. But the weird thing, and the point here about nailed to the craton, is that in most thrust faults, you break stratigraphy, and what ends up above the thrust fault is repeated below the thrust fault.
Mm-hmm.
Okay? There is no belt Purcell below the Lewis thrust fault.
Huh.
Every bit of belt Purcell is in the hanging wall of the Lewis thrust fault. There's no belt Purcell on the craton at all, right? What happens is you pass through the Paleozoic section right into the Canadian shield. So this isn't nailed to the continent in that there's no footwall belt Purcell. It could be, and probably is, extremely far traveled with respect to the cratonic basement that it's thrust over. So this comes back to, Basil's point is it's hard to put the boundary to the east, but it's not impossible. And the interesting thing about the belt Purcell, of course, is Basil's working on the Salmon River Suture Zone on the west side of the belt Purcell, and the Lewis thrust is on the east side of the belt Purcell. And so it's kind of a rogue element, right? It's hard to tie it specifically to North America, but it's hard to tie it to the intermontane and insular to the west. It's a black swan that's screwing us all up.
Basil, your reaction to that?
I think in Canada, that's exactly right. If you go into Montana, there's a couple, like the Little Belt Mountains, that occur east of the thrust belt that do pull up in a laramide style uplift the belt.
Huh.
But that just tells us that these rocks were probably deposited somewhere along the margin, but not where they are now.
Viewers, we're coming to you, and then you guys can bring in a slide again if you want, if we've got some that you still want to share, but we need to involve you guys. Jonathan, Stephen, why can't the Lewis thrust be one of the Baja BC faults in Alberta and Montana?
So we tend to think of, when we think about Baja BC faults, we think of the San Andreas, right? We think of the crust west of the San Andreas grinding its way north, past North America. And so we're kind of transfixed on looking for these vertical strike slip faults, especially if we think that everything is part of North America at the time, then we're stuck with looking for strike slip faults. The Lewis thrust is a beautiful thrust fault. If you ever get a chance to go hike along its eastern edge, Chief Mountain Klippa is just the most gorgeous hike to look at the Lewis thrust fault. So it cuts steadily up section, but is mostly parallel to bedding, right? We don't think of these as being the faults that carry Baja BC North, but it could be. Like there could be a lot of displacement to the north along that thrust. And the assumption is always simply that its last gasp is demonstrably pushing things east over North America, but it may have accommodated a lot of north motion of everything carried above it. A great point.
Yeah. Karin, what is pulling/pushing North American plate if you don't have westward subduction?
Nothing. I mean, for geophysicists, that's frustrating. And if you look at the geometry of the Mescalera slab wall, so under the eastern seaboard, and if you look at it in a reconstruction, it exactly parallels where the central Atlantic opened at that time. So it's like the perfect fit for pulling open the first stages of the Atlantic.
Do you have ribbon candy under the intermontane now too, and westward subduction beneath it? Or no, you had eastward, or do you? What do we know about intermontane now in your models?
You mean the before 170 accretion events? So that's under. Yeah. So that's slabs under the central Atlantic. There are slabs. It gets a bit iffy to make the connection because the absolute reference frame, so where in absolute terms Pangea is reconstructed, gets less certain. So there's basically two candidates, and both of them have a bit of we're not totally happy with them, but I mean there's also reasons why they could be the right ones, but what we really need is a better absolute reference frame, and in order to get that, we have to understand the old slabs that rim Eurasia, because that'll nail Pangea.
Wow.
And then because the problem is that North America in the Pangean, I mean, really, that after the seafloors disappeared, right? Seafloor lives 60 million years on median, so it's really not old. And the oldest seafloor slivers are 200 million years, which is as far as we go back. So really what we know beyond that is a lot of it is owed to the lucky fact that there was a supercontinent and all the continents together. So we get a lot of geologic ties, and the positioning comes from PaleoMag. And so, but it's very robust PaleoMag because you can use a pole on North America and a pole on Asia, and because they were all together, it's valid for all of Pangea, at least plus minus. But it's still not it's still not good enough to do this kind of. We're talking basically the distances are too small, and that we're trying to argue. So we need a mantle reference frame.
Thank you. Lon wonders, for Basil, where is more research needed in any of these topics? Where are you still going to Churn Creek, Basil?
Yeah, I'm going to Churn Creek. I will get there. So if to test Stephen and Bob Hildebrand's model, we should drill PaleoMag on the early Cretaceous in California, on the sediments, because if those things are in place, it's really hard to make a ribbon continent out of them. That I think is testable, though they have the right rocks at the right place, and there's places where they're tilted up. So you could actually test that there.
The problem, sorry, Basil, but the problem is overprinting, right? Finding a primary remnants is going to be tough. But I totally agree with you that is something that needs to be done.
The other problem is the Carmax. The Carmax and the Yukon Tanana all together. We have to restore it and figure out what in the world that little chunk of real estate is doing, because it's kind of the joker in the deck, right? If any model that could really explain that well would go a long way, in my opinion. The PaleoMag seems pretty good on it.
Well, that's what Mark is asking. Stephen, what is the CarMax group telling us about Northward translation?
I would never have gotten to the ribbon continent model without the CarMax group. So it is the Joker, as Basil says, and the reason we sampled it in so many places over several years is because the implication is stunning. You've got to go into continental rocks to find the boundary that accommodated the translation recorded by the CarMax group.
Thank you. I think it's time for some final thoughts. It's 10:30 here. I don't know, thinking back to earlier letters in the alphabet and guests that we've had, has anything surprised you? Thank you for watching these, you guys, and being so into what's happening here. You can take this wherever you want, but like, is there something that just immediately comes to mind? Like, wow, I'd never even heard that person talk, and I was like, damn, okay, I got to learn more about that. Anything come to mind with this series?
They were all very interesting. I mean, all of them were surprising on some level to me. And it's yeah, you've rendered a great service, Nick, because it's, I suppose it's not, you know, it's been done for a long time, the Baja BC, and hasn't been settled. And it means it's not a vibrant discussion anymore, but it is not settled. And so giving so much space to everybody to explain themselves in long form has been hugely valuable, I think. And yeah, there are all kinds of surprises to me.
Thank you. Guys, anything specific?
I think, sorry, Stephen, I like the paleomagnetist. I'd not ever talked to Jane Wynn. I really enjoyed that. Randy Ankin, I thought, was eminently quotable on a variety of different levels. And I particularly like, just get us more data. I'm not afraid of data. And it was that kind of, I like the openness to what he was trying to say with that, which is, we don't know, right? So let's just get more data. Let's figure out where the best data is, and let's work together to try and figure it out. And I also think that this approach, once you have that much strike slip, you need the people in Canada to be talking to the people in Mexico and everywhere in between, because it's no longer, this shallow slab's lovely because you don't ever have to go out of California. But once it's a bigger issue than that, then you do. And Karin's data is on the scale of that, and the PaleoMag's on the scale of that. And so you kind of have to be willing to talk with other people and sort of really, stress test their data to see what's a model and what's data, and can you make it work?
Thank you, Stephen.
I'd echo Basil's comments and say I'm always recognized how lucky I was to spend so much time with Randy and Jane. They're so entertaining in a short interview. You can imagine what spending summers with them is like. And I think I'd apply that to this entire series of interviews. Is the thing that impressed me the most was just kind of the joy and reason people had. Everyone loved their topic, and everyone was great at bringing forward the data that they understood and that they in many cases have produced, and its implications for the debate. And I thought that was fantastic. I mean, a lot of the problem has been that instead of trying to find an answer, science often is falsifying models, and we get too carried away with falsification and thinking that that's the end of it. And I think what I really loved about this whole series and about all of the guests was we got beyond the falsification and started trying to find answers.
Thank you for that, Stephen. I think that's enough. I've used up enough of your valuable time, Karin. It's late and Saturday night for you. So thank you so much, all three of you, for this. What a great way to finish what we've done here this winter. And I look forward to seeing combinations of you in May down in Reno, Nevada, and in August in McCall, Idaho, and beyond then as well. So thank you and goodbye to each of you.
Round of
Bye.
applause for you, Nick.
Oh, thank you. Thank you. No, that's fine. Thank you. All right, you guys. We'll see ya. Bye-bye. Kicking you out, kicking you out, kicking you out. All right. Well, that was delightful. I hope that you were able to follow much of that. I have seen some of you make comments either here or by email or whatever, and you're like, basically, I'm just shocked I could follow along with what those folks were saying. And that's because you have been loyal to what's been going on here. You haven't just popped in for one half of one episode. You've been in this for a while. And yeah, we just keep chipping away at learning some new things, and it's gratifying. And I'm talking about myself as well. I wouldn't have been able to follow most of today if I hadn't have been working with you to learn just block by block, brick by brick. I forgot to go to the laptop because I was so excited to get to those guys quickly. And so I want to go to the laptop now, and that will then finish things out. We're going to get another look at a couple of these figures by our guest today. And then, yes, of course, we'll wrap up the series and talk about what's next. So we go to the laptop and we go to nickzentner.com, heard of it. And we click on Baja in the upper right-hand corner, and there's not a lot for you, but shocking to me was a brand new paper co-authored by Basil. I didn't even know this existed, and he just sent this slyly a couple days ago and said, yeah, would you post this one? So to be honest, I ran out of time. I didn't have a chance to even read this very much, but it's written in a style. This is Basil and some co-authors. I think they're kind of setting up the Penrose conference. They're trying to identify questions, and I noticed that many of you in the live chat today were asking about, where do we go from here, and what kind of work is going to be done, etc. And there's some sexy looking maps here from these folks. Basil used this one today, for instance. So I will enjoy reading this when I have a little bit more time this coming week, and as I get ready. So that's waiting for you. That's a brand new paper. This, thank you to David, one of the viewers, David, who took the Clannett animation, the movie, and got it frame by frame. How do I do this? Frame by frame. So I didn't take the I didn't take the time after sketching things out on the chalkboard to then go back to Clannett's model. And this is Karin Sigloch's student at Oxford in England. But yeah, David made this for us because he saw that I was struggling with that animation and trying to freeze frame it. So you can go 1 million year by 1 million year with the fixed archipelago model. Thank you, David, for that. And Stephen, just yesterday, I think, said, yeah, why not? Would you mind sharing my 2007 paper on the Cache Creek terrain, which you remember Mitch Mahalanuk is thinking might be very important if we continue to look for a major Baja BC fault. And yeah, from the last show, you remember Danny Coots in his cushy high-rise in downtown Vancouver. He rewatched the session Y at home later that night and noticed that a bunch of you wanted his diagram that he made for us. And so here it is. He spruced it up even more, I think, and then said, please post this. Looks like the viewers wanted that. So that's a new addition since last time. Okay, so that's our last look at nickzentner.com. And yes, if I go back, this will stay like this. And you'll notice that, I don't know if you've noticed, but the past alphabet series last winter, those papers are still all there. If you're going back and watching past alphabet series, and I don't know if you've ever noticed, but I have an audio podcast that I do, and I post the episodes there. I have all sorts. What's going on here? Hello, McFly. Hello. I guess the website. Maybe I didn't pay my annual fee here. I can't get to those. Whatever. Moving on, boy. Something's going on with the internet, apparently. Well, no, are we still functional? Wait. I hope we're still talking. What's going on here? You still here? That website wasn't working. Oh, we're good? Okay. So let's, here's all the slides that, no, sorry. So this is just, I guess, a quick little look at key images from papers. Here's the ribbon candy underneath a fixed insular. One more time, a look at Karin's suture. Karin and Mitch. I still want to learn more about that. We didn't quite get there today. It's okay. We covered a lot of ground. I really enjoyed it. Yeah, here once again is the fixed archipelago movie that you can watch. And here's Basil, who was skipping around a little bit. Again, we wanted to be as fluid as possible, but I wanted to give you a chance to look, at least freeze frame a couple of the slides from Basil as well. Some interesting points. Look at this. The Jurassic has a nice collision, but the Cretaceous, that was a whopper. And yeah, I love these new maps from the new paper, the Busby paper. What does it say? Not much is where it was at 100 million years ago. If you want to understand the Cretaceous, you have to undo the, if you want to understand the Jurassic, you have to undo the Cretaceous. Props to Todd Lamaskin for making this really attractive looking ocean floor here. Love that look. Don't think I understand what's going on, but it'll take me a little while to figure it out. Yeah, and so Basil had these ready to go in case we wanted to go there with our discussion, but here's a chance to look at them a little more carefully. You remember Basil had his jagged coastline of old North America and the role of those sticking points, essentially. Oh, forgot he had this. He might have made this for us, Basil. He's got the ribbon candy underneath it. Okay, so here he is. Basil, hit and run model. Let's get rid of the Mescalera Ocean, at least at our latitude, by subducting on both sides, volcanic arc on both sides. Huh, interesting. In case we need a map, yeah. And then here's Stephen. I had Plutons really far inland in his Amanika. I still think I want to do more with the Amanika down the road because I will eventually return to the North Cascades. Yeah, so the younging of the Plutons that Stephen was talking about here are all out in the water with a westward subduction. Oh, good Lord. These are the plots from that Odyssey of the Cache Creek paper, which I don't think I understand quite yet. Yeah. Okay. End of this winter's series. I thank you for being part of it so regularly, both live or in replay. And to talk about what's next, let's start with the most immediate thing. What's next immediately with these exotic terrains is a month from now, I am giving 4 downtown lectures, a return to live lectures in an auditorium. And if I would have tried 4 lectures on exotic terrains in 2020, I wouldn't have had much to say. So I've learned a lot. So I've seen from many of you in the live chat today and in past shows, you need 3 more letters. You need 4 more letters. Aren't you going to like summarize everything that you've learned? You're just going to leave it open like that? So the answer is yes and no. Yes, we're at Z. There aren't any more letters. We're done. And yes, it's open-ended and there's plenty of more work to be done, and that's how we're closing. So there's no more letters, but I think you can view the 4 downtown lectures in Ellensburg here next month as essentially me trying to take everything that we've learned this winter, last winter, and the winter before, and boiling it down in my own way to 4 live lectures. So let's talk a little bit more about that. I will have 2 of the big chalkboards up on stage. This is the venue. It's called Morgan Performing Arts Center. It's a middle school that's been restored. It's a beautiful old building, and the auditorium is just gorgeous. And you may have seen the opening, the only time. I did 4 lectures in that venue in April of 2019. And there's an opening kind of drone shot, kind of zooming in. These are the windows of the Morgan Auditorium facing west. So you're looking east. You know, my house is just a few blocks away. And this is where you will enter if you decide to come to these live lectures. And this is what it looks like inside. And these are photos from those 4 lectures that I did 4 years ago. On the main floor, there's about 500 seats. And there is a balcony, and there's about 200 seats up there as well. So 700 seats total. And this is the way the venue looks. And as I just mentioned, I started from scratch during the hardest part of the lockdown, during the pandemic, where we were all trapped at home. And I started on September 9th of 2020, just with the most basic stuff involving exotic terrains. And yeah, my old friend Larry the Ladder and the iPhone and the old little Blackie chalkboard and Cozy Fort and all that stuff. It seems like a million years ago, and at the same time, it wasn't that long ago, man. It's 3 years ago. You kidding me? It was 3 years ago. Sorry, Patrick. So let's thank the guests that I've had this winter, give you a little bit more detail about the Morgan Auditorium talks, and a few other things I have up my sleeve before we say goodbye for real. Mescalera Ocean, aka Ingalls Ophiolite, Baja BC. I did this last winter at this time. Can I please just thank all of the geologists who gave of their time and energy to be part of this winter's series. In order of appearance, I would like to thank Linda Nosen, Missoula, Montana. Darrell Cowan, Seattle, Washington. Basil Tikoff, Madison, Wisconsin. Jerome Lessman, Nanaimo, British Columbia. Danny Coots, Vancouver, British Columbia. Will Matthews, Calgary, Alberta. Paul Link, Pocatello, Idaho. J. Brian Mahoney, Eau Claire, Wisconsin. Aaron Donaghy, West Lafayette, Indiana. Robinson Cecil, Northridge, California. Margie Russmore, Los Angeles, California. Bob Miller, San Jose, California. Kirsten Sauer, Winthrop, Washington. Stacia Gordon, Reno, Nevada. Bernie Housen, Bellingham, Washington. P. Jane Wynn, Sydney, British Columbia. Randy Ankin, ditto, Sydney, British Columbia. Karin Sigloch, Nice, France. Mitch Mahalanuk, Victoria, British Columbia. Stephen Johnston, Edmonton, Alberta. Robert S. Hildebrandt, Tucson, Arizona. Erica Boudreau, Lowell, Massachusetts. Rich Gashnig, Lowell, Massachusetts. Joanne Nelson, Victoria, British Columbia. And Chris Mattinson, Ellensburg, Washington. Thanks to all of those geologists. So I think it's official. I'm going to do those 4 lectures 4 nights in a row at the Morgan Performing Arts Center that I just told you about. There's the address. I think I am going to call them the Mount Stewart Lectures. Thank you for all your input and your ideas, but I think that's what I want to do. So I'll just be referring to them as the Mount Stewart Lectures. And you're like, what the hell? You're going to do 4 hours on Mount Stewart? It's not that interesting. Well, no, Mount Stewart is just the excuse to then get into all this stuff as far-ranging as what we were talking about today. And the lectures are at 7 p.m. each of those nights, Wednesday, Thursday, Friday, Saturday night, 700 seats. Doors open at 6:30. Festival seating, is that what you call it? Free and open to anybody. I appreciate all the interest. I've already gotten a ton of emails like, can I buy tickets? Can I reserve my seat? Talking to me, can you rope off 5 seats for me and my friends? We're going to come up from California. You can understand, I hope, that I can't deal with all that. Like many things here, I want this to be, my tendency is to make things as simple as possible. So that's what I'm saying. These are free lectures open to anybody, and there's 700 seats. And I don't know, are we really going to have 700 people there? Yeah, maybe we will. I don't know. I think, although I'm not sure, that I'm not going to really advertise in the usual places. Oh, okay, here's a thought right now. So maybe, I guess I'll make a video next month sometime, mid-March or whatever. I'll make a short video about like where to park and which doors to go in and that sort of thing. And that'll be on the YouTube channel, and maybe that'll be it. Maybe that's the only way so it'll just be like people who watch the YouTube stuff and a little bit of word of mouth, I guess, but like maybe that would keep the numbers down a little bit. If we're worried about a sellout or what, well, I'm a sellout, obviously. No, I'm not. I'm not a sellout. We're never doing money here. We're never doing money. Forget that. But what I'm saying is if all the 700 seats are taken, I'm going to feel really badly if people can't get in, but I don't know what else to do. I don't want to book something way bigger than that because I have no idea how many people are going to show up. So, Morgan Performing Arts Center. There'll be a video on this next month. Let's say that. Not open to the public, but just we've referred to it a fair amount. There will be a special session or symposium, or I don't know what the hell we call it, from the Geological Society of America in Reno, Nevada, and I will be there during these dates in May. And many of the folks that you know from this series and plenty others, geologists, professional geologists will be at this session. And my plan is just to sit in the audience and take a bunch of notes and continue to learn about these concepts. And so, again, this is really not open to the public, I don't think. No, I don't think it is. So just letting you know that that's coming. And where I will continue to learn new things about these exotic terrains. And I, to be totally honest, forgot to mention this again with Basil, but maybe he doesn't know any more about this than he did last time. Because Basil's involved, and Basil is big into this accessibility and this free and open stuff like we've been doing, attending this conference is also closed at McCall, Idaho. I think there'll be like 75 geologists who are coming from around the world, I guess. I don't know. Basil's in charge along with Stacia Gordon and a few others. Will Matthews, those are the leaders of this thing, and one other gal from Mexico who I don't know. But I'm sharing this with you and reminding you of this, that Basil does want to involve people who have the ability and freedom in their schedule to come to Central Idaho, to come to McCall area. And I think, although I'm not sure, that maybe August 16th and 17th or something like that, like mid-August, before the conference, I think Basil's thinking like, yeah, we'll just, we haven't talked about it, but I'm thinking Basil will say, Nick, can you make a video in July or something and say, here are the details, and here's whoever wants to meet us in Idaho, we're going to do a field trip. I think he's serious about it. To almost like run the field trip, like practice the field trip with us before he does it for real. And I don't know, but I think that I'll be able to live stream from this Penrose conference and somehow involve you guys. I don't know, inside, outside, campfire, I don't know. But there is a public portion of this Penrose conference happening in August, and you have the dates, and I'll just try to keep you posted once we learn more about that. I haven't even showed you this stuff yet. It's like I'm going way too long here, but whatever. It's the last show. What do you want? Okay. I don't know if you're asking, but just in case you are we doing another alphabet series next winter? Yeah. I love this format. We've done a lot of new things this winter with this A to Z series compared to last winter. Next winter will be different yet. That's what's so fun about this. It's not just the learning new things. It's the experimenting. And I have the freedom to do that here. I don't really belong in a PhD world. Those really aren't my people. I don't really belong in a high school classroom either. That's a bit too rigid for my taste. My wife teaches at a high school in town, and she has to teach all this stuff multiple times a day, and it's very rigid. So I chose this gig on purpose long ago because I knew I'd have academic freedom to teach how I wanted. And if I could convince somebody to hire me without a PhD, just with a master's degree, this is before the internet, by the way, but I knew I'd have I'd be able to kind of fly under the radar essentially and do what I want. And so I'm grateful to Central Washington University for not getting in my way. And they're vaguely, the president and these folks are vaguely aware of what's going on, but they're not sending a well-dressed person down to my level and saying, knock it off, you're violating rule number 72.3. They're not doing that. I'm sure I'm violating 7 rules right now. So I'm grateful to have this opportunity to keep doing these kinds of things. And just the doing it is the reward for me, nothing else. So yeah, I want to keep going with the alphabet thing, but I don't know. I maybe have poked and prodded enough where maybe next winter's live stream series from November to February, I'll probably stick with Wednesday and Saturday. Maybe I'm going to choose something different. Maybe I'm done with exotic terrains with our alphabet. I want to keep the format, but maybe, I don't know. What do you think? One thought is Cascade volcanism. Have 26 shows, 26 different researchers on Rainier and St. Helens, and there's plenty to learn there. How about Cascadia earthquakes? You know, earthquakes, Pacific Northwest earthquakes A to Z, 26 of those. Maybe Ice Age floods, 26 of those. Karin Sigloch by email said, I noticed your live chat keeps talking about the mantle plumes and stuff. Why don't you do one on that? Why don't you do a whole alphabet on mantle plumes? So I go, well, I would learn a lot there if I did that, because I don't know a damn thing. So I don't know. I think last February at this time, I announced Baja BC, and I said, I'll see you in 9 months, and we're doing Baja BC. Well, I'm going to see you in 9 months for this live stream thing. Again, this format, we'll strike it up in mid-November, but I don't know the topic. So does that mean I'm not going to see you until November? Of course not. So you maybe are aware that there are 25 101 class sessions that I live streamed. Talk about a violation. I'm sure that was a violation. University let me do it. I guess. I didn't really ask. And 2 springs ago, I worked with my 351 students, and we were looking at the Eocene, and that then sprung into, or that evolved into, the crazy Eocene A to Z. Well, I've already got a bunch of students signed up for 351 for next quarter, and that will start in April. And yes, we're going to do research papers on the Ice Age floods. And yeah, we're going to have Jerome Lessman down here working with my students, and Sky Cooley over here working with my students, and maybe I'll get some others, Brian Atwater, Richard Waite, Vic Baker, Bjornstad, O'Connor. Try to get as many of those guys in the field with my students, or possibly in the classroom with my students. But I don't know how much I'm going to be live streaming. That is a question mark. So there will be some videos coming this spring involving the Ice Age floods. My mind will be on the Ice Age floods for sure, all of April and most of May, even into June. But I'm not prepared to promise anything specifically. I need to think more about it. Will I do some pop-up geology things? I think I'll try. I had trouble with the audio. I wasn't happy with the audio. I need some new microphones for that. I now have a Starlink dish, which I haven't even gotten out of the box yet, but I want to practice learning how to use that so that I can live stream with good internet from a remote place. I'm excited about that. I like the concept of meeting you in the middle of nowhere and having a live session out in the field. There were some obstacles that I'm hoping to avoid in the future. So there will be some pop-up things. There'll be some field videos just as I'm out there learning on my own, probably related to the Ice Age floods this spring. So no schedule, that'll be fun to post things just whenever I do things. And hoping to do more with Backcountry Gary, whether he's here or not. Learning from whomever I can. be back into the Native American stuff, which I'm looking forward to visiting again with Randy Lewis. Hope if he's up for it, making more videos with him, his nephew John, and others. There's a lot of interest for sure, and you guys continue to be interested in what's happening here, which is delightful. Okay, so this is it. I think I'm done with my announcements, but I have one final thing. Toasts, and then a special package that arrived yesterday at the house. So let's do the toasts first. A toast to you. Thank you for everything. Thank you for being here so regularly and showing all the interest. I would definitely stop doing all this if nobody was on the other end. So thank you. Here's to your health and the health of everyone in your community. Here's to our guests today, Karin Sigloch, Basil Tikoff, and Stephen Johnston. What a thrill. What a thrill to have them all here together. Here's to those three. Here's to my dad, who passed away in July of 2019. And we had many discussions about communicating to the public. And he was a longtime public school teacher and a farmer and was very interested in these topics. I wish you could have seen all of this. Here's to Carl Zentner. And here's to Merle Beck, who did see much of this and passed away last month, January of 2023. Here's to you, Merle. So what arrived at the house yesterday? A small box that cost like $48 in postage from Michael in Janesville, Wisconsin. Yeah, same guy that made all the printouts. This is all Michael, who's been out of control with his printer. Well, he didn't turn off his printer. He made something else for us. It's not even that heavy. I don't know why something would cost $48 to spend, but thank you, Michael, for the investment. Pull my tail. It's very clear our love is here to stay. Together we're moving a long, long way. It's very clear. Our love is here to stay. I love you. Goodbye. Forever will. We always.